Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at an example from section 8.3. This is using the law of cosines to solve for the angles and sides of a triangle. Here they give us the three sides of a triangle. This is one of the two different cases that we can use the law of cosines for. The other case is for when they give us the two sides and the included angle. So in both of these cases, they don't give us enough information in order for us to use the law of sines. So here we're going to have to use the law of cosines. So the law of cosines is going to look like this. It's three different formulas, but it's really the same formula, just depending on which angle you really want to solve for, A, B, or C. And in the case where they just give you the three sides, it doesn't really matter which one of these that we use. So let's go ahead and jump in and just use the middle one there, and that way we'll go ahead and solve for angle B. Now remember, I went ahead and already notated it, but the names of our sides will just be the same as the opposite angles. So the side opposite angle C will be lowercase c, and so on and so forth. So if we're going to use this second equation here to first solve for angle B, I'm just going to substitute everything in here. So B squared, so that's going to be 4 squared is equal to A squared, 2 squared, plus C squared, which is 5 squared, minus 2 times A, which is 2, times C, which is 5, times the cosine of B, which is what we're really solving for here. All right, so we got this big old equation, and notice that we only have one unknown, which means that we can solve for that unknown. So working that out, we're going to have 16 is equal to, that's going to be 4 plus 25, so that's going to be 29, minus 2 times 2 times 5, so that's going to be 4 times 5, so that's going to be minus 20, times the cosine of B. All right. And then we can go ahead and subtract 29 from both sides. So 16 minus 29, 16 minus 29 is negative 13. So negative 13 is equal to negative 20 times the cosine of B. So divide both sides by negative 20. So 13 over 20 is equal to the cosine of B. Apply the inverse cosine to each side, and we'll end up having B is equal to the inverse cosine of 13 over 20. And let's see what that's going to be equal to. So we'll go out 2 decimal places on this, and we'll make sure that we are in degrees. So inverse cosine of 13 over 20 is 49.46. So 49.46 degrees. All right, so that is our B. And now we have enough information to finish everything out using the law of sines. Well, we'll need to use the law of sines for the next one, and then the final one we can just subtract those two from 180. So let's go ahead and next, doesn't really matter here, but I'll do the sine of, we know the B, so that's 49.46 over little b, which is 4, is equal to, and we'll do the sine of, Let's find little a first. So sine of a over 2. And okay, give me just a minute here. So we're going to end up getting that the sine of a is equal to 2 sine of 49.46 over 4. So that means that a is equal to, or the inverse sine of 2 times the sine of 49.46 all over 4. And let's go ahead and take a look at that. So second inverse sine of 2 times the sine of 49.46, close parentheses, divided by 4. And let's see what we get here. We get 22.33. So that's approximately 22.33. Now remember, we did an inverse sine here, so we also have to look at the possibility of having the angle of 180 minus that. Second answer. So we also have to look at the possibility of 157, although 157 plus that 49 is going to be well over 180, so that is not one of our possibilities here. So we can discard that being one of our possibilities. So this is going to be good. And then finally, we can just take these two, subtract them from 180 to get our last angle here. So that is A. So C is going to be 180 minus 49.46 minus 22.33. And that's 108.21. So C is 108.21. And that's it. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.